synthesis of how ocean acidification and anthropogenic global climate change negatively impact Pacific sand dollar survival. Dendraster excentricus by
Penelope Dysart-Haynes
and Cecily Davis.
Before we start our presentation, we'd like to acknowledge that the Portland metro area rests on traditional village sites of the Multnomah, Wasco, Cowlitz, Willamette, Clackamas, bands of Chinook, Tualatin, Kalapuya, Malala, and many other tribes who made their homes along the Columbia River. Indigenous people have created communities and summer encampments to harvest and enjoy the plentiful natural resources of the area for the last 11,000 years. We want to recognize that Portland today is a community of many diverse Native peoples who continue to live and work here. We respectfully acknowledge and honor all Indigenous communities, past, present, future, and are grateful for their ongoing vibrant presence. We also acknowledge the systemic policies of genocide, relocation, and assimilation that still impact many Indigenous Native American families today. As settlers and guests on these lands, we want to respect the work of Indigenous leaders and families and pledge to make ongoing efforts to recognize their knowledge, creativity, and resilience.
Outline. First, we're going to do an introduction to ocean acidification, or OA. Then we're going to talk about sand dollar's ecological role as a marine organism, and then discuss the direct and indirect impacts of ocean acidification on sand dollar biochemistry, as well as future recommendations and solutions to help the sand dollar.
Acidification. Ocean acidification is caused by an increase in carbon dioxide. As you can see in the graph on the upper right, carbon dioxide in the atmosphere bonds with seawater, forming carbonic acid, which dissolves into free hydrogen ions and bicarbonate ions. Our oceans are a carbon sink, so much of the CO2 that's released into the atmosphere from things like burning fossil fuels ends up in our oceans. Free hydrogen ions reduce the pH, making the ocean more acidic. pH is measured on a logarithmic scale, so small differences in pH can have huge effects. Around 200 years ago, the global ocean pH was 8.2, but it's now decreased to 8.1, endangering calcifying organisms like the Pacific sand dollar. This rate of change of 0.002 pH units a year. As you can see in the diagram on the lower right, an increase in carbon dioxide showing an increase in carbon dioxide leading to acidification.
Dendroster excentricus. The familiar outer shell of sand dollars we find on the beach is actually the endoskeleton of the organism. The shells mirror the inside structure, a feature referred to as petaloid ambulacra. When alive, the sand dollar takes on a more purple or gray appearance and is covered in small spines, such as seen in the images. The sand dollar is a calcifying organism, meaning they create their endoskeletons by extracting carbonate and calcium ions from the water to create crystal calcium carbonate that can be used to form the endoskeleton. The free hydrogen ions in the water bonding with the calcium ions, as well as making bonding more difficult for the Pacific sand dollar. Sand dollars also have a cloaca, which they ingest their food, such as small waste in the sand or small plankton that get caught in their spines. They also use the cloaca to excrete waste. Sand dollars reproduce by clustering together in groups and letting out eggs or sperm, depending on the sex, into the water to be fertilized, known as passive reproduction. Sand dollar fun fact. Sand dollars go by many names around the world. Some include sea biscuit, sand cake, and cake urchin. Trivia. Test your knowledge of the Pacific sand dollar. Do you believe sand dollars are omnivores, carnivores, or herbivores? Pause and guess. The correct answer was omnivores.
Article analysis of sand dollar fertilization success based on temperature and pH. A study done by ResearchGate showed that over time, more exposure to high temperature decreased the fertilization rates of sand dollars. Using water with an 8.2 pH, which is a weak base, to simulate ocean acidity. High temperatures often mean high carbon dioxide amounts in the water, creating a more difficult environment for sand dollars to bond with calcium carbonate ions. Without structurally sound endoskeletons, the organism cannot protect itself, and with limited resources, reproduction becomes a low priority, which could lead to a decrease in the population, as you can see in the graphs by ResearchGate on the right. Once temperature reached around 25 degrees Celsius, fertilization rates dropped from 100 to 80% success to around a 50% success rate. With temperatures warmer than 25 degrees, fertilization success rates decrease even more. The lower graph displays the same data with a regression line.
Life cycle of a Pacific sand dollar. Sand dollars grow in 3 stages. After a group of sand dollars has gathered to reproduce, the males and females release eggs and sperm into the water. The fertilized eggs then eventually turn into larvae. As you can see on the far right image, it is sand dollar eggs under a microscope with a magnification of 100 times. They're invisible to see with the naked eye. During the stage of larva, the larvae survive off of microscopic plankton floating in the water. As you can see in the middle image, this is a bilaterally symmetrical larva that aimlessly floats around. After 3 months, the larvae become the recognizable coin shape they are so famous for. During this stage, sand dollars need the most amount of carbonate ions to create a healthy endoskeleton. As you can see on the far left image, this is a fully grown endoskeleton that is a live sand dollar. Artistic response. My partner and I both created an artistic interpretation of sand dollars because it's a project that our school will often do when we are learning about a new subject. I chose to make a clay model of a sand dollar, and I created it by taking 2 endoskeletons of dead sand dollars that I found on the beach and covering them in a thin layer of clay. And then I sculpted on the familiar flower pattern onto the top. And then I added more texture to the one that's alive to show the stark differences between live Pacific sand dollars and dead Pacific sand dollars. And On the other side, I also added the small lines that come out from the center where the cloaca normally would have been. The nice thing about using a real sand dollar as a base was that there is an actual hole in the bottom.
Artistic interpretation of the Pacific sand dollar, I chose to sculpt it out of clay. I wanted half of the sand dollar to represent a living sand dollar and half of the sand dollar to represent a sand dollar endoskeleton. For the living side of the sand dollar, I chose to paint it purple because that's the color that a live sand dollar usually appears as, and I chose to paint on some texture because Pacific sand dollars have those. On the side of the sand dollar that's supposed to represent a dead sand dollar, or the endoskeleton, on the right, I chose to carve out lunals, which are the small, long holes that appear on a sand dollar, and I chose to paint it white. Analysis on how ocean temperatures are rising and impacting weather events. As we previously stated, our oceans are a carbon sink, but they also store excess heat from our atmosphere. This is specifically impactful for coastal regions and species like the Pacific sand dollar. Rising temperatures negatively impact the reproduction of the Pacific sand dollar, as seen in previous slides. In the graph on the right, you can see that in the past 20 years, ocean temperatures have risen significantly, with surface temperatures spiking even more than below temperatures. This also leads to not just more extreme weather, but less predictable weather.
Based solutions. The ocean is a huge place, so slowing ocean acidification may seem daunting. A good way to decrease the hydrogen plus ion concentration is by focusing on a small patch of ocean and trying to lower the temperature. This is referred to as localized ocean cooling. This can be achieved by planting high carbon sequestering plants such as kelp, seaweed, or mangroves. These plants don't just help water temperatures decrease, but they also supply edible organic material and create new ecosystems, encouraging biodiversity. The images on the right side of the slide depict different type of high sequestering plants, and the chemical equation on the bottom left illustrates photosynthesis.
Call to action. Sand dollars are ocean janitors, essential to keeping the seafloor clean. They're crucial to the marine ecosystem, from oxygenating sand to providing sustenance for species that occupy a higher trophic level in the marine food web. A way to directly protect these creatures is by voting for laws promoting sand dollar conservation, or signing ocean protection petitions and voting for laws. Improving marine health is a great way to start helping these organisms. It's also a good idea to visit beaches and support local businesses that help marine protection.
The sand dollar, Dendraster excentricus, is a calcifying organism that creates its endoskeleton by extracting carbonate and calcium ions from the water. Sand dollars are crucial to the marine ecosystem, but ocean acidification makes it more difficult for them to reproduce. Ocean acidification is a harmful process caused by an increase in carbon dioxide and increased concentration of free hydrogen ions, which reduce the pH in ocean water. The current pH is now 8.1. The effects of ocean acidification will continue to negatively impact the sand dollar because they are unable to reproduce, causing an exponential decrease in population.
Thank you for viewing this presentation by Penelope Desartains
and Cecily Davis, Northwest Academy students. We hope you learned something about the Pacific sand dollar.
If you have any questions or want any more information, please reach out to our chemistry teacher, Molly Sultani, at msultani@nwaacademy.org.
Bye!
Thank you!
Images cited. Images cited.